for our last section in chapter 11, we're looking at the binomial theorem, which helps you if you have a problem like this, so that you don't have to FOIL over and over and over and over again. So this is our shortcut, this Pascal's triangle, and when you get to the test, you're going to have to create this, which is really easy once we figure out what the pattern is. But this is the shortcut to finding the answer to this problem so that you don't have to write this quantity out 6 times and FOIL it.
Why do we learn how to do it?
Because when you just have 2 terms, it's a lot quicker to just FOIL. But this has 6 quantities. All right, so this is what you're going to want to write down. So this would be what you would start with. Okay, so they're going to give you a problem. Now the A and the B are just in there arbitrarily so that you know that it's going to start as a quantity with a power on the end. Okay, so for instance, right here, we would need to expand it to the 6th power because that's what this problem is right here. Now, looking at this pattern of numbers, does anyone see how we could fill in these blanks very easily based on what's already up there? What would the next number be?
7.
Nope, not 7.
9.
Not 9.
And then 8.
Not 8.
Oh, it goes back. 5, 4.
What's this one going to be?
4. And then another one's going to be 5. Those would be 7. 4.
They're not 7s. Not 11s. You're all very close, but you haven't picked the right.
12.
It is 10. Why is it 10? What, Claire? The 2 numbers up above it added together give you that number. So the ends are always 1. What's this one going to be? Because the 5 and the 1 is 6. This one is 2. So that's how you're going to create Pascal's triangle when you get to the test. So you'll want to do that first before these problems. So I'm going to go through and show you how to do these. So these numbers right here, you'll want to, so these numbers, all right here in Pascal's triangle, are the coefficients, so they're the numbers in front, when these quantities are expanded. So I'm going to show you how to do that on the next page.
So it doesn't always start like that. That's not how the triangle looks.
This triangle will always look this way.
Or if we have to write it down.
Yes, and this shouldn't be a 0. This should be a 1. That's a typo. So the 1s kind of create the framework, and then everything else you just add the 2 numbers above it to get the next number to build the inside. Questions?
Will always be the same.
In Pascal's triangle?
Yeah.
Those will always be the same numbers, yep. Questions? All right, so here's how this works. Let's say this was our problem. What I want you to do is to draw a blank and then write x to the 5th, t to the 0, plus blank. So write out this whole thing, and I'll explain why in a second. What's the pattern that you're seeing here as you're writing them down? Yep, so the first term, which is x, those exponents start at the 5 and go down, and then the second term, t, will start at 0 and go all the way up to 5. So that pattern always happens. So there's really 2 things going on in these problems. we need to do those exponents, the first one decreasing and the second one increasing. And then we just need to throw in the coefficients from the Pascal's triangle and we're done with the problem. So instead of doing this and actually multiplying them out with FOIL, this will be our answer and we will be done. So looking at the Pascal's triangle where we have a 5, these are the numbers that we put in those blanks. And then we're done with the problem. And you didn't have to do any foiling or anything like that. So what are those numbers? And you're done.
Do you have to write all that X stuff?
Yes, because that's part of the answer. But let's simplify it a little bit so that it looks a little bit cleaner. What is anything to the 0 power? 1. So really this is just x to the 5th, because we don't need to write a 1 in front of it. This one would be 5x to the 4th t, 10x to the 3rd t to the 2nd, so that would be your answer. So if we were going to FOIL this and we were going to multiply all of this and take all the time to do that, we would get a bunch of like terms that we would end up putting together. This does all of that in one step for you. So there's no multiplying out, there's no finding all the common terms and putting them together. It just gives you the answer right away.
So you always start the first one at one number.
We always start this one with the highest exponent. We always start this one with 0, and then we just work opposite directions. So we are going to expand this one using the regular way. This is the only time we're going to do this. Okay, we'll do this with the window, because that's typically what kids tend to like doing. So we're just going to do these first. So 2x plus 5, 2x plus 5. So we have 4x squared, 10x, 10x, and 25. Do you agree? So this part of the answer would be 4x squared, and then what's this term going to be? 20x plus 25. And then we still have to multiply this by 2x plus 5. So we haven't done that part yet. We just multiplied the blue underlined part. So then we can create another window with our 2x plus 5 here, 4x squared, 20x, and 25. And we'll just multiply the left and the top on these. 8x to the 3rd, 40x squared, 50x. Did I make any mistakes? And then there's a few things that we can combine for like terms, right? So our answer will be what? Plus
60x squared.
Okay, so we got that after multiplying all that out. Now, I'm going to show you how we can use Pascal's triangle. We're going to do a little bit of simplifying, but it's not going to take all of this work right here. Okay, but it is a little bit different than this problem that we did up here, because instead of just having an x and a t, we have a 2x and also a 5. But the process is still the same. Okay, so what I always do is I start with the coefficients. So we have a problem where we have a cubed. So on that row, we have a 1, 3, 3, and a 1. So right here we have 1, 3, 3, and 1. Because whenever we have something to the third power, we follow this arrow, and there's 4 terms right there. Mm-hmm. Yep. All right, and then in parentheses, we didn't do that up here, but it just makes it a lot easier. You're going to have your 2 terms in these parentheses, and we're going to change the exponents on them in the same pattern that we did on the previous one. So this just makes it a little bit cleaner, especially since our first term has 2 things in it. It has a 2 and an x. So I'm going to write the 2x and the 5 in each of these. And then the exponents, is the 2x going to start at 3 or 0? So 3, 2, 1, 0. And then these ones start at 0, 1, 2, 3. And they always follow that pattern. Now the only thing we have to do is simplify each of the terms. And then we have our answer. So there's really only 2 steps. This one had multiple steps when we did it this way with the windows. This one we just have to simplify each of our terms. So let's look at the first one. We have a 1, we have a 2x, the whole thing to the third power, and we have a 5 to the 0. So the 5 to the 0 and the 1 are just 1, right? So we don't have to worry about that. We just have to take 2x to the third power. What would that be? Remember, when you have an exponent out there, you have to cube both of them. 8x to the third power. Everyone agree? Okay. Here, we've got a whole bunch of numbers that we're going to multiply together. So let's take this slowly. We've got a 3, and then we have what in here? A 4, and then we have a 5. So 3 times 4 times 5. What is that? 60. And then we have x to the second power from right here. Okay, let's look at our numbers here. We have a 3, we have a 2, and what's 5 squared? So we need to take 3 times 2 times 25. 150 and just an x, right? X to the first power. And what about over here? This is 1, 2x to the 0 is 1, and this is 125. Now this should look very familiar to you from what we found on the other process. Other questions? Yes?
So x to the 0 is not x?
Nope, anything to the 0 power turns into 1, whether it's a letter or a number. Anything to the 0 power. Questions? I'm going to try 2 more. Ready to move on? All right, last slide. We're going to do this top one, and the bottom one we're just going to set up but not do the simplifying step, just to make sure that we're all okay with the setup. But when you have a minus, this is what you need to think of it as. So after you write x minus 3 to the 4th power, write it like I wrote it as well, just to remind yourself that you need to think of that minus as really attached to your second term. So that's a negative 3. All right, so looking at Pascal's triangle, I'm not going to flip back to it. Looking at the one that has to the 4th power, what are my coefficients? 1, put that on silent, please. All right, and then after that, I always put my parentheses. And in those parentheses, I put the two terms. So we have x and -3. And then I do the exponents. So on the x, am I going to start with 4 or 0? Okay, so I'll do all of these first. 4, 3, 2, 1, 0. And then this one starts at 0, 1, 2, 3, and 4. Now we just simplify each of those 5 terms. So, looking at this one, what's the only thing that we're going to have to write down? Yep, because this is 1, this is 1, so the only thing here is x to the 4th power. And here, what are the numbers we multiply together? We've got 4 here, and -3 to the 1st power is still -3. So that's going to be what? -12. So I'm going to change this plus sign to be minus since it's -12. And then x to the 3rd power from right here. Okay, this term. Numbers here, this is a 6. What about here? +9, because -3 times -3 is +9. So 6 times 9 is 54, and x to the 2nd. On here, we've got a 4, we have an x, and what is this going to be? -27. So what's 4 times -27? And then just x, right? And then what about here? It's -3 in parentheses to the 4th power. 81. There's your answer. So on the next one, we're just going to set it up. We're not going to do this simplifying step, but I want to make sure that we're clear on how to do this. So on our Pascal's triangle that we drew, do we have a to the 7th row? Okay, so let's add that. So on here, let's add a 7th. So we've got a 1 and a 7. Okay, so those are the numbers we write down first. Again, we're not going to do the simplifying step. We're just going to set it up. So remind me what those are. Okay. Put my parentheses. We've put a 2D and a 7. And then the exponents. So on 2D, we'll start with the highest and work all the way down. And then on the 7s, we would start at 0 and go up. And then we'd simplify. Other questions on that? So remember on the test, you'll have to create Pascal's triangle on your own. So you'll probably want to practice doing that when you get your homework assignment right at the top. See if you can recreate it so that you can reference it and use it the whole time. I believe there's only 4 homework problems where you set it up and simplify.